Dear students, Assalamu alaikum. I'm Dr. Jangres Khan for the lecturer of Economics of Environment and Natural Resources. The topic of our today's lecture is climate change. In this lecture, we will discuss different topics like what is climate change, the greenhouse gas emissions, and global climate change. Another topic, the evolution of international agreements on climate change, will also be discussed. In short, in this lecture, we will discuss the concept of the climate change and then the effect of the greenhouse gases. And at the end, we will discuss the different international agreements on the climate change, as we will discuss the efforts which have been carried out so far for the climate change. So, dear students, we know that pollution is a global issue. Sometimes it has no remains in a limit, while sometimes it crosses the boundaries. It becomes difficult to control when it crosses borders. Pollutants crossing the boundaries impose external costs, so emitters have no proper incentives for controlling them. Means that we know that the pollution is a global issue. Almost each and every country face the problem of the pollution. And we discussed in the previous lectures that not only whenever there is an economic activity, it is expected that there will be pollution. It will have negative externalities. So for the negative externalities, the pollution is within the borders, within the limits of a country. It is not very difficult to control such type of the pollution, but the issue becomes complex when the pollutants cross the borders of a country. It becomes because when it crosses the country, the emitters don't care for those that type of the pollution, and the history shows that often no proper incentives have been so far taken by the emitters to control the pollution because it doesn't damage their own country, own environment, but when it crosses the borders, the emitters do not have an incentive to control them. The cost of inaction are not limited to the damages caused International cooperation among such traditional allies as the United States, Mexico, and Canada, and countries of the Europe has been undermined by disputes over the proper control of the transboundary pollution. Means that the cross-boundary pollution, nobody accepts the responsibility, and even the good friends, United States, Mexico, and Canada, they have been always they have been allies. They don't care for it, and there are disputes among these countries over this issue. Now, what is climate change? A seasonal change over a long period of time with respect to the global accumulation of greenhouse gases emission. It is climate change is the seasonal change over a long period of time with respect to the global accumulation of the greenhouse gases emission. We will discuss it in the next slide in detail. That actually the climate change, one of the major reasons of the climate change is the change in the mix of the greenhouse gases. That is the reason that we are having acute temperature, and we are having unexpected events relevant to the weather conditions. The science of climate change. Now, how the climate change occurs. We know that the light from the sun is absorbed by land, water, and vegetation on Earth. When the sunrise falls on Earth, it is absorbed by land, water, and vegetation on Earth. It is transformed into heat and re-radiated in the form of invisible infrared radiation. These, when it is absorbed by land, water, and vegetation, through a process, it is transformed into heat and it is re-radiated in the form of the infrared radiation. Now, the Earth contains molecules that absorb this heat and re-radiate the heat in all directions. And such type of gases are called the greenhouse gases. These gases include carbon dioxide, various hydrocarbons, methane, nitrogen oxide, non-methane volatile organic compound, ozone, sulfur, hexafluoride, and water vapor. All these are the greenhouse gases, all these gases have a molecular structure made up of more than two component atoms that are able to vibrate with the absorption of heat. All these gases have molecular structure in which it has two or more atoms, and when they absorb this heat, it starts vibration due to the heat energy. Eventually, our vibrating molecule emits the radiation again, which is often reabsorbed by another green gas molecule. And when the vibration of the molecules occurs, we know that with the vibration, heat is produced, and this heat is emitted, which is absorbed by another molecule, greenhouse molecule, which is present in the atmosphere. Without the greenhouse effect, the mean surface temperature of the Earth would have be about 33 degrees Celsius lower than it is today, and most of the world oceans would have freeze over. Due to the greenhouse gases, the world temperature is normal, the Earth temperature is normal. In the absence of these gases, in the absence of the greenhouse temperature, the world temperature would have been very lower, and it would have been about 33 degrees lower than the temperature which we are having today. Due to greenhouse gas molecules, Earths enjoy a temperature suitable for life. As discussed in the previous slide, the greenhouse gases controls the temperature of the Earth, as discussed in the previous slide, that in the absence of the greenhouse gases, it would have been 33 degrees lower than the temperature we are having today. So it means that due to the greenhouse gases, we are enjoying suitable temperature. Water vapor is the most important, most dominant greenhouse gas in the atmosphere, but most attention is given to the carbon dioxide due to increasing atmospheric concentration originating from human sources. Now, among the greenhouse gases, the most abundant is the water vapor, but the environmentalist, the environmental economist, and the other relevant experts, professionals, they concentrate on the carbon dioxide, because in the carbon dioxide we see in the environment that its quantity, its mix is increasing due to the human activities on Earth. The chemical properties of various greenhouse gas molecules result in different capacities for absorbing heat in the atmosphere. These various gases, greenhouse gases, different gases have different types of the chemical properties, and that is the reason that all these gases have different capacity to absorb the heat. The concept of global warming potential (GWP) was developed to compare the ability of each greenhouse gas to trap heat in the atmosphere relative to another gas, usually carbon dioxide. When we talk about the climate change concept, global warming is often heard. It is a common concept. It means the ability of each greenhouse gas to trap heat in atmosphere relative to another gas, usually carbon dioxide. Means that it is the compared to it is a comparison of any gas to the carbon dioxide. The definition of the global warming potential for a particular gas is the ratio of heat trapped by 1 unit mass of greenhouse gas to that of 1 unit mass of carbon dioxide over a specific period of time. Means that the global warming potential is actually the ratio of the heat absorbed by 1 unit of a gas to that of 1 unit mass of carbon dioxide gas over a specific period of time. The mix and distribution of these gases within the atmosphere is responsible for both hospitable climate on the Earth and the inhospitable climate on Earth. The distribution and mix of these gases, these carbon dioxide, the water vapors, nitrous oxide, etc., these are responsible. All the hospitable events and inhospitable events occurs on Earth due to the mix and distribution of these gases. Changing the mix of these gases, however, can modify the climate. If there is a change in the mix, means that if there is increase in the one of these gases in the atmosphere or decrease in the one of these gases on Earth, it will result in modification in the climate, a change in the climate. The current concern over the effect of this class of pollution on climate arises because of a changing mix in the atmosphere. Burning fossils, leveling tropical forests, injecting more of the other greenhouse gases into the atmosphere, and humans are causing a rise in temperature of the Earth's surface. We know that we are burning fossils, we are burning due to the burning, due to the leveling the forest, forest degradation, and due to more and more exertion of the greenhouse gases in the Earth is raising, is changing the temperature of the world. It is increasing the temperature of the Earth. The International Intergovernmental Panel on Climate Change, IPCC, reported in its finding in 2007 on both the sources and likely outcomes of the change. Most of the global warming occurred during the last 25 to 50 years, and the criminal is the human activity. Most of the we see the global warming, the change in the climate, it occurred in the last 250 years, and the reason for this is the human activities. According to IPCC, the global increase in the carbon dioxide concentration are due to the fossil use and land use change, while those of methane and nitrous oxide are due to the agriculture. Means that when we see change in the mix of the carbon dioxide, increase in the exertion of the carbon dioxide, it is due to increasing the fossil use, fuel use. We are using fuel on a very wide range, and land use change. We are converting forests into the for the construction houses, for the construction of the different projects. We are the environmental degradation, and it is increasing the world temperature. Warming of the climate system is unequivocal. It is clear, and it is now evident from the increase in the global average air and ocean temperatures. When we talk about the climate system on the world on this earth, it is clear that the climate system is warming. The climate is warming. There is increase in the Earth's temperature, and it is clear from the ocean temperature and the global average air, and melting of the snow, ice, and rising in average sea level. Human-induced warming and sea level rise will continue for centuries as the human activities are such that it is changing the mix of the and distribution of the greenhouse gases. So if the human activities continues, if the economic industrialization continues, the use of the fuel increases, the exertion of the gases increases on the earth, the rise in the temperature will continue, and the process will continue for centuries. The global warming can cause contracting snow cover, shrinking sea level in the Arctic and Antarctic regions, and increasing weather events such as extreme heat, heavy precipitation, and intense storms. We see around the world extreme events, and these extreme events show the global warming. And this global warming is due to the climate change, and the climate change is due to the change in the greenhouse gases. Recently, scientists have also uncovered evidence that climate change may occur rather more abruptly than the previously thought. The scientists say that the process of global warming this this will continue more abruptly than the previous estimates. Since the rate of temperature increase is a significant determinant of how well ecosystem can adapt to temperature change, abrupt climate change has become a matter of more concern. An example of raises in the concern is the methane trapped in the frozen tundra of the north. Uh, this area, tundra, in the north of the Earth, the northern pole, with increase in the temperature, the tundra can melt and releasing the trapped methane. There is a huge reservoir of the methane there. If the temperature increases, the tundra will melt and it will release the methane, which will, methane is a powerful greenhouse gas, and this release could accelerate the rate of warming. An earlier working group of the panel tasked with the responsibility to find out came to several conclusions. Recent regional climate changes, particularly temperature increase, have already affected many physical and biological systems. No doubt, natural systems, including reefs, mangroves, and tropical forests, are vulnerable to climate change. Developing countries will have more severe effects of the climate change since they will experience multiple stresses and have the fewest resources to commit to adaptation. Adaptation is now necessary to address the impacts resulting from the warming that is already unavoidable due to the past emission. These threats pose a significant challenge to our climate. Now, dear students, are we up to the challenge? The mix is changing, the environment is changing. So, are we up to the challenge? Are we ready to accept the challenge? Are we ready to face the challenge? The answer is not clear because significant barriers confront with attempt to move toward a solution. Any action to moderate climate provides a global public good, implying strong possibility of free rider actions. Free rider effects not only cause emission to be abnormally high, but they also inhibit R&D investment, a key ingredient in promoting innovative low-carbon technologies. Free rider effects also inhibit the participation of nations in the climate change agreements that are designed to correct these market failures. And unlike the normal marketed good, the scarcity of a stable, hospitable climate is not signaled by raising prices of that good. To further complicate the matter, the damage caused by greenhouse pollutant is externally in both space and time. The largest emitters have largest capacity to reduce emissions, but they are not expected to experience as much damage from the insufficient actions. If the most of the controlling greenhouse gases is spared by the current generation, it will secure the future generations. Means that the development of in the world will continue. If actions are taken by some countries to control, to moderate the climate change, there are chances of the free riders who will not only discourage the moderation of the environment, but they also inhibit R&D investment. But if we invest in the current generations, we invest in the environment, our this cost will secure the future generations. International corrective action is both necessary and terribly difficult. The greenhouse gas emissions and global climate change. Now let us discuss the greenhouse gas emissions and global climate change. How the green gas emissions affect the global climate. Modeling carbon dioxide, modeling the carbon dioxide gas emissions. Human activities has increased concentration of carbon dioxide in the atmosphere. We know that due to the human activity, due to the economic activities, due to the use of the fuel, burning of the fuel fossil, due to the industrialization, the concentration of carbon dioxide has increased in the atmosphere. Several mathematical expressions that describe the primary factor driving anthropogenic greenhouse gas emissions with emphasis on the carbon dioxide. Anthropogenic means human greenhouse gas emissions. We can express it through different equations, and one of such type of equation is IPATE identity, where I stands for impact, P stands for population, A for affluence, and T for technology. The IPATE identity relates a nation or political unit's environmental impact in a given time period to the production of the population, product of population affluence, that is prosperity, which is measured by increase in the GDP per capita, and the technology, which can be measured in emission per unit of the GDP. According to this identity, the impact of the impact is due to the environmental impact is caused by the product of by three factors: population, affluence, and technology. Where affluence means the prosperity, which is made by increasing the GDP, and the technology. All these lead to the environmental degradation. This relation can be expanded a bit more even by Kaya identity, that is Kaya 1990. The carbon dioxide emissions is equal to, according to the Kaya, population multiplied by GDP per population, and multiplied by energy per GDP, and carbon dioxide by the energy. It tells us that this identity tells us that everything equal, other things remaining same, a country with small population or with lower per capita income of energy, or low energy intensity, or low carbon intensity, will have lower carbon dioxide emissions. This identity shows that a country with lower population will have lower carbon dioxide emissions. A country with lower per capita income, lower influence, GDP by population, will have lower pollution in form of the carbon dioxide emissions. Similarly, a country with low per capita energy will have also lower carbon dioxide emissions. A useful property of the multiplicator identity, such as IPATE or Kaya, is that growth rate in the energy related emissions is equal to the sum of the growth rates of each component. Thus, for the Kaya identity, we can this Kaya identity we can say that the percentage percentage growth of the carbon dioxide is equal to the percentage growth of the population plus percentage growth of per capita GDP, and plus the per capita the energy the ratio of the energy and GDP, and change in the carbon dioxide and energy ratio of the carbon dioxide and energy. According to Watson, Zenevra, and Moss 1996, worldwide energy-related carbon dioxide emissions have been growing at the average annual rate of 1.7% since the middle of the 19th century. According to these studies, the carbon dioxide emissions are have increased about 1.7% due to since the middle of the 19th century. According to Negosonovic, uh, this 1%, this 1.7% increase or growth in the annual emission is the sum of 1% annual growth rate in population plus a sum of plus a 2% annual growth rate of the per capita income and 1% annual rate of decline in energy intensity and 0.3% annual decline in the carbon intensity. The carbon intensity can improve if, for example, a given quantity of electricity is generated from burning natural gas instead of coal. We can, so far energy is concerned, we can, if the electricity is produced from burning natural gas by use of the natural gas instead of the coal, because we know that we have in our country also many IPPs, thermal plants which produce electricity from the coal. If this coal is replaced by the natural gas, then it is expected that we will be able to control the emission of the carbon dioxide. Energy intensity will improve if, for example, a given level of GDP is generated from more energy efficient capital equipment. Similarly, we can improve the energy capacity, energy intensity if a modern technology is used and new forms of the capital or equipment are used, which will reduce the exertion of the carbon dioxide in the environment. Reducing the carbon intensity of energy is not sufficient to assure a reduction in total carbon dioxide emissions. This is because while carbon intensity may fall, population growth and per capita GDP growth can swamp any improvement in carbon intensity. Dear student, it means that not only we showed here that not only controlling the energy capacity and the carbon intensity can improve the environment, but we will have to keep in mind these other factors like the population and the other per capita GDP growth to control the carbon dioxide emissions. Because for the GDP growth, economic activities will say accelerate. This will include the use of more and more fuel, the use of the industrialization, which will increase the per capita, which will increase the exertion of the gases. Projection for future carbon dioxide emissions usually assume continued decarbonization, though some experts believe that countries such as China, the United States, and India may decarbonize by substituting abundant coal resources for declining more costly and gas resources. Now, trends in the greenhouse gas emissions. What have been trend in the history in the greenhouse gas emissions? The carbon dioxide, the nitrous oxide, the water vapors. What the history shows? What has been the ratio of these gases in the environment? Along Earth's history, atmospheric carbon dioxide concentration fluctuated by 10% or more. If you look at the human history, the concentration of the carbon dioxide fluctuated in 10% or more in the atmosphere. Solar radiation in turn lead to glacial and interglacial cycle, and that atmospheric concentration of carbon dioxide naturally peak just before its ice caps fully melt at 275 to 300 parts per million. We also call ppm, according to Rodiman 2005. These carbon dioxide concentration then naturally declined for perhaps 15,000 years to an average of 245 ppm. Carbon dioxide and methane concentration have remained stable over the last 5 to 8,000 years, up to 1780, a deviation from the natural trend that Ruddiman hypothesis have. Key culprits in this model are the clearing of the forest and irrigation and flooding of the land. We also discussed previously that the destruction of the forest, the cutting of the forest for the economic activities for different construction projects, it is actually increasing the carbon dioxide emission on the atmosphere. And due to the flooding of land, also the forests are destroyed, and it is resulting in increase in the greenhouse gases, which is causing the climate change. If this hypothesis is true, then by late 1700, the cumulative effects of agriculture for 250 parts per billion ppb increase in the methane and 40% ppm increase in the carbon dioxide and average warming of 0.8 degrees Celsius. According to Ruddiman hypothesis about absent agriculture, average temperatures would have steadily declining and would have passed below the glaciation threshold about 5,000 years ago. As mid of 1700, mid of the 18th century, that is 1700, atmospheric concentration of the carbon dioxide stood at approximately 280 ppm, that is parts per million, which is a higher estimate than the Ruddiman. Starting in the late 1700s, beginning of the Industrial Revolution and rapid rise in the human population and atmospheric concentration of carbon dioxide began to increase, and as of 2005 had increased to the 380 ppm. Now, dear students, it is clear that as discussed previously, in the previous slide, I discussed in detail that the main culprit of the change in the greenhouse gases mix and the environmental degradation is the humans. Due to the human activities in the form of these economic activities in the form of the industrialization, the deforestation, and other such type of the activity, burning of the fossil, use of the coal on a very wide range for the generation of the electricity, has resulted in increase in the greenhouse gases emission, which is resulting in the climate change. According to IPCC 2001, the present carbon dioxide concentration in the atmosphere has not been exceeded during the 650,000 years and likely not during the past 20 million years. The current rate of increase is at least unprecedented during at least the past 20,000 years. The IPCC also provides information on emission trends for the other greenhouse gases. For example, they report that atmospheric concentration of the nitrous oxide has increased by 17% since 1750 and continues to increase. So, again coming to the human activities, due to the economic activities, due to the rapid industrialization in the 17th and 18th century, which also continued in the 19th century, the emission of the greenhouse gases not increase only in form of the carbon dioxide gas emission, but also of the nitrous oxide. The present atmosphere nitrous oxide concentration has not been exceeded during at least past 1,000 years. Similarly, about one-third of current nitrous oxide emissions and one-half of the current methane emissions are anthropogenic. So, dear students, As we discussed in the previous slides, that almost all greenhouse gases are emission of all greenhouse gases is due to the human activities, due to humans, and the especially the nitrous oxide emissions and one third of the nitrous oxide emissions uh, and half of the methane emissions are anthropogenic or due to the human activities. Trend data over the half century from Moala Observatory in the Hawaii indicate an acceleration in the rate of growth in concentration of carbon dioxide in the atmosphere. It's a study, it's an analysis of the Mauna Loa Observatory that the mix in the greenhouse, the mix of the greenhouse gases changed over the last couple of decades. Carbon dioxide concentration were only growing at the rate of 1.0 ppm a half century ago when the observatory was first made at Mauna Loa. Initially, when this observatory was established, when this lab was set, the carbon concentration in the rate of the carbon concentration was only 1.0 ppm, that is parts per million. Estimates of greenhouse gas concentration by year 2100 to 2100, that is the depend on changes in the energy-related emissions factors in the Kaya identity, as well as change in the land rate of deforestation, emission of sulfate aerosols among the factors. Future change in the factor is difficult to predict. So, according to the statement, according to the results and conclusion drawn by the Mauna Loa Observatory, the change in the greenhouse concentration, change in the greenhouse gases mix, it was due to the deforestation, rate of the deforestation, because as we discussed earlier that the deforestation is increasing around the world in developing countries and in even some of the developed countries due to the human economic activities. Similarly, emission of sulfate aerosols is also increases, which is affecting the greenhouse gas mix and the climate. So these are the reasons of the climate change. If the current 1.5 ppm, that is parts per million, growth rate were to continue to 50 years, for example, then by 2025, the atmospheric concentration of carbon dioxide would be a bit over 450 ppm, or approximately 1.6 times the pre-industrial revolution concentration of 280 ppm. So I'm again and again stressing the emission of the carbon dioxide, which is an important greenhouse gas and which is responsible for the hospitable environment on the earth fit for the human life. But unfortunately, due to the human activities, the carbon dioxide emission is rising, and it is estimated that by 2025, the carbon dioxide the emission would be 450 ppm, which is a very highest rate as compared to the previous rates, and it is about 1.6 times of the carbon emission rate before the industrial revolution, that was 280 parts per million. Moreover, if the 1.5 ppm growth rate were to continue for 100 years, then by 2105, the concentration of carbon dioxide in the atmosphere will be 525 ppm. So just compare the figures. Look here. Before the industrial revolution, in the 18th and 19th century, the carbon exhaustion, the carbon emission was 280 ppm, which is expected, which is predicted by 2055 is 450 ppm. And if this trend continued, then it is expected that the carbon dioxide emission would reach 425 ppm, which will completely change the greenhouse gas mix, thereby affecting the climate on the earth, therefore increasing the temperature on the earth and increasing the other the increase in temperature will lead to will accelerate the pace of the ice, the pace of the glacier melting, which will automatically increase the sea level. So if action is not taken, annual increase in the atmospheric concentration are likely to increase rather than stay the same. The previous data shows, and the predictions we discussed so far, these show that the carbon dioxide emission is increasing as it is estimated by 2055, but to touch the figure of 480 ppm, and in the next 100 years it will touch the rate of 525 ppm, 525 ppm, which will completely destroy our environment. The business as usual BAU forecast of IPCC predicted world's population to reach 9 billion by 2050 and global per capita income to be 3.3 times larger in 2050 than in 1990, and the energy intensity of economic activity is to be improved by 2050 to 60% of its 1990 value. Based on these projections, world energy consumption in 2050 would be 3 times larger than in 1990. So these estimates are alarming. These estimates are alarming because by 2050 the world population will increase to 9 billion, which means that according to the IPCC and Kaya identities, the greenhouse gases emission will increase as population is one of the important determinant of the environmental impact and the greenhouse gases emission. Similarly, the global per capita income to be 3.3 times larger than 2050. Similarly, the per capita income will increase, which means that the economic activities will be accelerated. The economic activities will rise. So, due to increase in the economic activities, which will also include the industrialization, expansion of the industrial capacity, the use of the fuel for the energy production, all these will automatically affect the exertion of the carbon dioxide and other greenhouse gases, and the energy intensity will also rise by 60% by 1990. So, according to the Kaya identity, the environment will deteriorate. There will be climate change. There will be changes in the climate and increase in the temperature. These predictions show, which were forecasted by the IPCC. So these forecasts show that there will be deterioration of the environment. There will be much climate change. If the carbon intensity of the world energy supply continues to fall at BAU rate of 0.2% per year, This scenario would entail world carbon dioxide emissions from energy sector to 2.7 times bigger in 2050 than in 1990. The US emissions have risen by 13% during the period 1990 to 2002, which is a very high emission, which is affecting not only the environment of the United States, but it is also affecting the world environment. It is affecting the ozone layer. It is increasing the world temperature because 13% increase in the emission is a very large figure. Global climate change predictions. Now, what will be the effect of these trends, these increase in the exhaustion of the different gases? What will be the future predictions? It is more difficult and controversial to predict global climate change than to predict future greenhouse gas emissions. As the previous studies of the IPCC and other agencies showed a climate change, the exhaustion of the greenhouse gases. But climate change is something different from the greenhouse gases emission. So we can predict the greenhouse gas emission by looking at the trend of the industrialization, by looking at the trend of the energy intensity. But it is difficult to predict the global climate change. Climate models are extremely complex. Moreover, in addition to relatively smooth cause and effect relationship between the greenhouse gas concentration and temperature, there is potential for abrupt and dramatic changes. So, as we have discussed again and again, there is a deep relationship between the greenhouse gas emission and temperature. So, any dramatic climate changes can occur. According to Schwartz and Rendell 2003, fresh water from the melting glaciers can abruptly slow the North Atlantic Ocean's thermohaline conveyor. This can reduce the average temperature in the northern Europe by 6 degrees Fahrenheit in a 10-year period, and 30% decline in the rainfall as well as significant declines in agriculture production. According to this study, if this trend continues, then it is possible that in the future that there will be an average reduction in the North Europe temperature by 6 degrees Fahrenheit, and as well as a reduction in the rains. Similar disruptions of thermohaline conveyors in other areas of the world's oceans make this a problem of potential global concern. Such disruptions are not only limited to the Europe, but the other areas of the world also have the same problem, which is creating the potentially which is creating the global concerns. According to study, these disruptions could persist for as long as a century, as they did the last time on an Asian conveyor collapsed due to these effects 12,700 years ago, and again 8,200 years ago. In 1990, the IPCC estimated average forecast in temperature at the Earth's surface ranging from 3 to 10 degrees Fahrenheit by 2050, with the most likely increase being nearly 5 degrees. You know that IPCC carries out its research and make predictions about the changes in the climate, changes in the greenhouse gas mixes. So it is expected that most likely there will be increase in the temperature by 5 degrees Fahrenheit by 2050 in the world. The IPCC issued a mid-year range estimate for global warming in longer term of 18 degrees Fahrenheit. In January 1996, the IPCC lowered projected rate of the warming over the next century by 30% compared to its 1990 assessment. This downward adjustment occurred due to including more variables and interactive facts into the climate change model. For example, the new model included emission of the traditional pollutants such as sulfates and uh, carbon CS aerosols, which cool the atmosphere by reflecting incoming solar radiation and eroding the reflective properties of clouds. These are other emissions, sulfates, which also affect the properties of the clouds, thereby uh, thereby changing the rate of the rains. We see today extreme events, extreme weather conditions. These gases, these pollutants uh, are responsible for such type of the global events. Sulfates and aerosols may have marked one half of the heat trapping impacts of increased concentration of greenhouse gases. Another reason for downward revision in the climate change forecast was the decline in projected chlorofluorocarbon emissions. Similarly, not only carbon dioxide but chlorofluorocarbon emissions are also part of the part of the greenhouse gas mix, and these also affect the environment. And the emission of the chlorofluorocarbon is also increasing. The 1996 estimate for global warming predicted a mean surface temperature rise by 1 and 3.5 degrees Celsius by 2100. Harris, Kattenberg, and Maskell provide climatic change predictions drawn from improved understanding of the factors driving greenhouse gas emissions and land use changes. So let me make the settings. Yes. So the Harris and Kattenberg and Maskell study also show that the environment can be improved by understanding its factors. While these storylines predict widely different carbon dioxide concentration in the future, the midpoint of these predictions suggests atmospheric carbon dioxide concentration of approximately 750 ppm by 2100. So, dear students, looking at the history of these carbon dioxide emissions, it is very dangerous because the previous estimates we saw 280, then 280, then 480, then 525, and now another prediction 750 ppm by 2100. The midpoint of these two lines predictions suggest an approximate doubling of the annual atmospheric nitrous oxide and methane emission by 2100. Consequently, the global average surface temperature is projected to increase by 1.5 to 500.8 degrees Celsius by 2100. This finding is in line with the previous findings of the IPCC and other findings that it is expected that by 2100 the average temperature will increase up to 5.8 degrees Celsius. Hansen 2004 argues that rising sea levels are the dominant issue in global warming, since a large share of the world's population lives within a few meters of the sea level, along with trillions of dollars of infrastructure at risk. So, with the increase in the exertion of these environmental gases, the greenhouse gases, the world temperature will rise. So, due to rise in the temperature, the glaciers will melt, and the melting of the northern pole Antarctica and tundra region will increase the sea level. And we know that around the world, trillions of dollars infrastructure is on the beaches. With increase in the sea level, this infrastructure will be at risk. Similarly, another study by Levitas report that the heat content of the world oceans has increased by 10 watt years per square meter in the past 50 years, and that the rate of ocean heat storage in the 1990 is consistent with the Hansen estimate that Earth is retaining between 0.5 and 1 watt per square meter. Given the current level of annual climate forcing, that amount of the oceanic heat could be accumulated in 12 to 25 years. An interesting effect of the global warming appears to be the warming effect daily minimum temperatures from more than daily maximums, thus lengthening the growing season in many temperate areas around the world. Del Genu and Fung studies show that this increase in the daily minimum temperature coincides with the global increase in thick precipitated clouds as might be expected from the greenhouse effect. And these clouds tend to reduce the nighttime cooling. Hoy 2004 provide climatic change predictions for California using two different climate models. That is the parallel climatic model and the Hadley Center climate model, and several different future emission scenarios drawn from IPCC. The Hadley Center predicts that the emission of these gases, global average temperature will increase by 3 centigrade and mean sea level rise by 40 centimeters by 2080. It is also an alarming figure. That the world temperature will rise, according to this study, the world temperature is expected to increase by 3 degrees Celsius, which will automatically increase the melting, will accelerate the pace of the melting the glaciers, which will increase the sea level about 40 centimeters by 2080. Land areas will warm twice as fast as that of the oceans, and winter high latitude temperature will warm more quickly than the global average, as will areas of North and South America, India, and Southern Africa. The 40 centimeter rise in the mean sea level forecasted by 2080 is estimated to increase the annual number of people flooded from 13 million to 94 million. An increase, according to the Hadley Center report, an increase in temperature up to 3 degrees Celsius by 2080 will bring about a big change in the greenhouse mix, in the extreme weather conditions. Due to extreme weather conditions, flooding will increase, and the effects of the flooding will increase from 13 million to 94 million. 60% of this increase will occur in Southern Asia and 20% will occur in Southeast Asia. Large changes in precipitation, both positive and negative, are anticipated in the tropics. The center predicts a substantial dieback of the tropical forests and tropical grassland by 2080, especially in northern South America and central South Africa. Considerable growth of forests is predicted to occur in North America and Northern Asia and China. These predictions are alarming. The greatest increase in the risk are projected for China and Central Asia. Epstein 2000 reports that the predicted increase in temperature will be broaden the range of the mosquitoes carrying not only malaria but also dengue fever and yellow fever and several other kinds of the diseases. Predicted increase in the flooding events will not only create ideal mosquito habitat but also increase the spread of the cholera and other waterborne diseases. Such climate change will increase the rains, flooding, and the flooding will provide a habitat for the mosquitoes, and it is expected that we will face uh, many waterborne diseases in the different regions of the world in form of malaria, dengue fever, yellow fever, and other diseases. The Health Center predicts that human-induced warming will reduce the risk of mortality in many large temperature zones, and the estimated reduction in the winter-related mortality exceeds the increase in the heat-related summer mortality. According to the USGCRP 2000, the warming in the 21st century will be significantly larger than the 20th century. The predictions we discussed so far by the IPCC and different researchers show that the global warming there will be global warming, and the global warming is clear from the events occurring around the world. Scenarios examine the assessment which assume to no major intervention to reduce the contribute growth of world greenhouse gas emissions, and it indicates that the temperature in the United States will rise by 5 to 10 degrees Fahrenheit, that is 3 to 6 degrees centigrade on average during the 21st century, which is more than the projected global increase. The assessment report that natural ecosystems are especially vulnerable to the harmful effects of the climate change, since there is often little that can be done to help them adapt to the projected speed and amount of change. Some ecosystems that are already constrained by climate, such as alpine meadows in the Rocky Mountains, are likely to face extreme stress and may disappear entirely. The untimely rains, the floods, the extreme temperature will definitely affect the alpine meadows, not only in the United States but around the world. It is likely that other more widespread ecosystems will be vulnerable to climate change. One of the climate scenarios used in the assessment suggests that the potential for a forecast of the southeast to break up into moist forest, savannas, and the grassland. Several of the climate scenarios suggest possible changes in the species composition of the northeast forests, including the loss of sugar maples. Another aspect of the USGRP includes an examination of the potential effects of the climate change on different regions of the United States. For example, rising sea level will likely cause further loss of coastal wetlands and put coastal communities at risk of storm surges, and especially in the southeastern region of the United States. As the earlier predictions showed, that we will have extreme weather conditions, floodings, rise in the sea level, which will affect not only the southeastern region of the United States but around the world in similar areas. Reduction in snowpack will very likely alter the timing and amount of water supplies, potentially exacerbating water shortages and conflict, particularly throughout the western United States. It is forecasted that annual average temperature will increase, ranging from 3 to 0. The melting of glaciers in high elevation west and in Alaska represent the loss and diminishment of the unique national treasures of the American landscape. Large increases in the heat index and increase in the frequency of heat waves are very likely. Similarly, in various parts of the nation, cold weather recreation such as skiing will very likely to be reduced, and air conditioning usage will very likely to increase due to the increase in temperature. Another assessment predicts some positive impacts from the global climate change in the 21st century. For example, crop and forecast productivity is likely to increase in some areas for the next few decades due to increased carbon dioxide in atmosphere and in extreme growing season, extended growing season. The assessment state that U.S. exports could increase depending on impact in our other food growing regions around the world, and that rise in the crop production in fertile areas could cause prices to fall, benefiting consumers. Other benefits that are possible include extending seasons for construction and warm weather recreations, reduce heating requirements, and reduce cold weather mortality. Finally, the GCRP assessment points out that there is also very likely to be unexpected impacts of the climate change during the 21st century. Some surprises may stem from unforeseen changes in the physical climate system, such as major alteration in ocean circulation and cloud formation and storm. Due to a change in the mix of the greenhouse gases, the, the temperature will rise. There will be climate change, which will bring about a change in the alteration in the ocean circulation, in the clouds formation. Maybe there may be very rainy clouds and increased storms. In addition, unexpected social and economic changes, including major shifts in wealth, technology, or potential priorities, could affect our ability to respond to climate change. Policymakers are confronted with the challenge of devising greenhouse gas policy in the next context of uncertainty. Thus, we are conducting a natural experiment on the planet, the outcome of which may range from moderate to catastrophic, and which will last well beyond the human scale of lifetimes. Thank you very much. This is the end of the lecture, and for this, this material has been taken from mainly from the book of the Ahmad Hussein, and the references are given at the end. These are the references, including the Hussein, Kaya, IPCC, and etc. So the lecture is based on the material taken from the Ahmad Hussein